This will be a presentation on understanding and interpreting odds ratios by Polly Quinn. Odds ratios are a measure you will come across in literature that are usually expressed like this. Before interpreting what these numbers mean, it's important to understand why odds ratios are used and what they're used for. Researchers use odds ratios when faced with a research question that seeks a dichotomous outcome, that is, an outcome of only two possible variables, such as getting the flu or not getting the flu, or increasing calcium intake or not increasing calcium intake. These are usually case control studies, but odds ratios are also used in cohort studies and cross-sectional studies sometimes. Odds ratios measure the association between an exposure and an outcome. For example, the association between drinking kombucha and improved gut health. Odds ratios can be useful in interpreting the overall effect of an intervention. Using the kombucha example again, how do we apply the odds ratio? Let's say we have 100 people in a group receiving the intervention of drinking kombucha, and another 100 people who are not. Their results look like this. Of the 100 who consumed kombucha, 43 had improved gut health, and 57 did not. Of the 100 who did not consume kombucha, 16 had improved gut health, and 84 did not. To find the odds of improved gut health for each group, those with the outcome are divided by those without the outcome. So 43 divided by 57 gives an odds of 0.75, and 16 divided by 84 gives an odds of 0.19. These odds tell us the likelihood that each person in the groups of 100 had the outcome of improved gut health. Now to compare the two groups, we find the ratio of these odds. This is done by dividing the odds of the first group, 0.75, by the odds of the second, 0.19. This gives us an odds ratio, or OR, of 3.95. Remember that the odds ratio is a measure of association between an intervention and an outcome. So how significant is this association between kombucha consumption and improved gut health? What does 3.95 mean? For odds ratios, the point of no difference, or the point where there has been no change or association, is 1. We can interpret whether our result is significant based on where it lies in relation to 1. A result higher than 1 shows a positive association, and therefore is significant. As with our kombucha gut health example, an odds ratio of 3.95 indicates increased odds that a person who drinks kombucha will experience improved gut health. But what if our odds ratio is less than 1, for example 0.7? Being less than our point of no difference, 1, the intervention actually reduces the chances of the outcome occurring and is also statistically significant. Only odds ratios of 1 are not statistically significant, as they show no association between the intervention and outcome. As a rule of thumb, case control studies should have an odds ratio of greater than 4 to be impressive. What about the confidence interval of the odds ratio? As shown earlier, an odds ratio is usually reported with a confidence interval following. For example, odds ratio of 3.8 with a 95% confidence interval between 1.6 and 8.7. As the confidence interval does not include the point of no difference, it is considered statistically significant. But if it looked like the second example, odds ratio of 3.8 with a 95% confidence interval of 0.3 to 8.7, it would include 1 and therefore not be statistically significant in reporting association. So from this video, I hope you now understand how an odds ratio is calculated, what it is used for, and how it is used. Thanks for watching.